Okay, in this video, I'm going to show you how to set up the experiment for the specific heat of metal samples and provide some sample data as well. So to begin with, let's look at our equipment. We have our balance, our tongs, our graduated cylinder, our styrofoam cups, which will serve as our calorimeter, our metal sample. In this case, I'm using a steel alloy, which you can see the little FE on the middle there. Our TI Inspire with temperature probe, our stand to hold the thermometer, and our hot water bath. Now, the hot water bath should already be going, and our metal sample needs to go in there for about 10 minutes once we test the temperature. So we're going to double check with the digital thermometer, which is shared, that our temperature is about 96 to 100 degrees Celsius. That's in the right range. So we're going to use our tongs to carefully pick up our metal sample, and we're going to gently place it into our hot water bath. And we're going to let that sit for about 10 minutes. So we check the time, it's 2:25 now. We'll come back to this at 2:35. What we are going to do while our metal sample is heating up is we are going to get our water sample for our calorimeter and set up our Inspire. Now, the cylinder that we're using is relatively small. If we were using one of the larger aluminum cylinders, which looks like this, so if we're using a larger cylinder, we're going to use close to 300 milliliters of water. With the smaller cylinders, we can use anywhere under 100 but greater than 40. So we're just going to fill that at the sink. As long as we record the exact amount that we use, we are good. All right, we have our liquid in there. We're going to see if this will focus. Remember, on these graduated cylinders, each line is worth 1 milliliter. All right. So this looks like it is right on the 61 milliliter line. So we would add that to our data table. So our mass of water used. Now remember, water has a density of 1 gram per milliliter, so 61 milliliters is 61 grams. And then we're going to add that into our styrofoam cups here. Now, to set up our TI Inspire, first we're going to press the on button to turn it on. Should look like a home screen like this. Then we put our temperature probe into the EZ-Link. It only clicks in one way. We then take the end of our EZ-Link and plug it into the top of our calculator like that. And the DataQuest app should open automatically. Now, if there's already data on here, and no matter what you do, you're going to press the menu so we can put this away. We're going to go into Experiment, and then we're going to select New Experiment. Do we want to save all of our data? Sorry, do we want to clear all the data? Yes. Now, it's seeing our temperature probe here. We want to be in time-based, rate 2, and then we're just going to change the time here. So we're going to scroll down to duration, click on that, and punch in 300. So that should give us more than enough data points. And then we're going to press OK. Our calculator is good to go. So now we're going to take our temperature probe, put it through the stopper there, Move our cables out of the way, making sure those don't get wet. Put our temperature probe down into the liquid without puncturing it into the cup and knocking everything over. All right, so we can see our temperature probe is in the liquid, and we can record the initial temperature of the water. And again, you'll do this on your data table. So we're going to record that as 22.9 degrees Celsius. All right, if we check the time, it is 2:35 on the dot, so our metal sample has been in the water for about 10 minutes. We're going to use the digital thermometer to record the temperature that our metal is starting at before we add it to our calorimeter, just in case it is not 100. So before we transfer things, we're going to grab our stir rod that was hidden earlier, set that over here. We're going to take our temperature with the digital thermometer. Again, we're sharing these between stations. All right, so we're going to put our temperature probes, our thermometer, in the hot water bath. We'll give that a moment to stabilize. Again, when we're doing this, we don't want to be touching the metal or the glass. We just want to be holding it in the water. And our starting temperature of the metal looks like it's still climbing. We can safely call 98.5. So we're going to write that down in our data sheet. Now we're going to go to our TI Nspire, and we're going to click the green play button so it starts collecting data. Don't worry about the scale on the graph here. It will zoom in when we're done. So we go to our sample, we take our tongs, we reach in, we carefully pick it up by the top and transfer it directly into our styrofoam cup and give it a little swirl. We don't want to stir it up too much though, because that will put some heat into the mixture. All right, so we can see here on the graph that the temperature is starting to rise, and we're going to let this sit until the temperature looks like it stabilizes. All right, we can see here that the temperature looks like it is leveled out, so we're going to go ahead and stop it now. And we can see it hit its maximum and then was just starting to cool a little. So, to get our data here for the maximum temperature, we can either click on the graph at the highest point, which looks to be about here, and then we can read it over here at the side of 30.1, or we can also just run some statistics real quick. So if we press Menu, and then we go to the Analyze menu and hit Enter, and then scroll down to Statistics and hit Enter again. This tells us that our minimum value was 22.86, which was our starting temperature of 22.9. And now we can get our final temperature, which we know from thermal equilibrium is going to be the temperature of the metal and the water. By looking at the maximum value on here, which was 30.1. degrees Celsius. So now we should have everything for our data table. We have the mass of water, used in the experiment, we have the initial temperature of the water. We have the final temperature of the water. We also have the identity of the metal used. So we're going to write Fe/steel alloy. Now what I forgot to get at the start was the mass, so we will get that in a second. We have the initial temperature of our metal, and we have the final temperature of our metal. Because I forgot to get the mass at the start, we're going to have to take it out of the cups and dry it real quick. All right, now that that's dry, we're going to turn on our balance. We're going to let it wake up. Wait for it to display all zeros, which this one will do after the countdown. We can put our metal sample on there, and then we can record our mass. So 57.84 grams. Now for our data, just in case we miss something, we're going to click OK. Then we're going to click the check mark to save the data for right now. If we need to refer back to it, we can scroll down here and then scroll here and click Run 1 to redisplay our data. And now we can use this information to go through the analysis questions.